Hello everyone, today I'm going to explain the topic security of Java servlets. In simple terms, this topic is about how we protect web applications built using servlets from hackers, data theft, and misuse. So let's begin with an introduction to servlet security. Java servlets are server-side components that handles client requests and generate dynamic responses on the server. They form an important part of many web applications. Because servlets deal with user data and requests, security becomes a critical concern. The main goal of servlet security is to protect web applications from unauthorized access and potential malicious attacks. In most cases, security is managed by the servlet container itself. This means the container automatically handles important tasks like authentication and access control, reducing the burden on developers. Overall, servlet security ensures safe communication between users and the server, protects sensitive data, and controls access to resources. A well secured servlet application not only improves system reliability but also builds user trust. Now let's understand the role of servlet container in ensuring security. A servlet container such as Apache Tomcat or Jetty plays a crucial role by automatically managing many security aspects of web application. First, it handles authentication, authorization, and request processing without requiring the developer to implement everything manually. This reduces complexity and minimizes chances of security mistakes. Second, it provides built-in security mechanisms such as login configuration and role management. These features are available out of the box, making it easier to secure applications efficiently. Another important benefit is the separation of concerns. The container takes care of security, allowing developers to focus on business logic. This improves code maintainability and organization. Overall, servlets containers like Apache Tomcat and JT offer robust and reliable security implementations, making them essential components in building secure web applications. Now let's look at two important approaches to implementing security in servlets: declarative security and programmatic security. Declarative security is defined using configuration files like web.xml or through annotations. In this approach, security rules are set outside the actual code. This makes it easier to manage and update security settings without modifying the application logic. It also provides a centralized way to handle security. On the other hand, programmatic security is implemented directly within the servlet code. Here, developers write explicit logic to handle authentication and authorization. This approach is useful when security decisions need to be dynamic or based on specific conditions. Each method has its own advantage. Declarative security is simpler and cleaner, while programmatic security offers more flexibility and control. In real world applications, both approaches are often combined to create a more flexible and powerful security system. Now let's explore some key methods used in programmatic security within servlets. The first method is authenticate response. This triggers the container-based authentication process for the current request, allowing the server to verify the user's identity. Next is login with username and password. This method allows the application to perform authentication manually by passing user credentials directly within the servlet. The logout method is used to end the user session. It removes any authentication data, ensuring that the user is securely signed out of the application. Finally, each user in role checks whether the current user has specific role or permission. This is especially useful for controlling access to certain features or resources based on the user roles. Together, these methods give developers fine-grained control over how security is handled within their applications, especially when more dynamic behavior is required. Now let's look at the different authentication mechanisms available in servlet security. The first is basic authentication. This method uses a browser pop-up to collect the username and password. It's simple to implement but not very user-friendly and should always be used with HTTPS for safety. Next is form-based authentication. This allows developers to create custom login pages, providing a better user experience and more control over the interface. Digest authentication improves security by sending hashed passwords instead of plain text. This makes it more secure than basic, although it is less commonly used today. Finally, client-side authentication uses SSL certificates to verify the user's identity. This is a very strong and secure method, often used in high security environments. Choosing the right authentication mechanisms depends on the security requirements, user experience, and sensitivity of the application. After authentication, the next step is authorization. Authorization determines what resources a user is allowed to access once their identity has been verified. In other words, it controls what actions a user can perform within the application. A common approach used here is role based access control or RBAC. In this method, users are assigned specific roles such as admin or user, and each role has its own set of permissions. These roles are typically defined in configuration files or through annotations, making it easier to manage access rules in a structured way. This approach ensures that the users can only access the resources they are permitted to, preventing unauthorized actions. Proper authorization is very important because it helps reduce the risk of privilege escalation attacks, where a user might try to gain higher level access than intended. Now let's move on to session management and secure communication. In web applications, session IDs are used to maintain user state across multiple requests. Since HTTP is a stateless protocol, session IDs help the server remember who the user is. However, these session IDs must be protected. One way to do this is by using secure cookies. By enabling flags like HTTP only and secure, we can prevent client-side scripts from accessing cookies and ensure they are only transmitted over secure connections. Another key aspect is using HTTPS. HTTPS relies on SSL or TLS protocols to encrypt communication between the client and the server. This ensures that sensitive data such as login credentials cannot be intercepted by attackers. Overall, secure session management and encrypted communication are essential to prevent risks like session hijacking and data breaches and to maintain user privacy. Finally, let's look at some additional security components and best practices for servlet applications. First, servlet filters act as gatekeepers. They intercept incoming requests and outgoing responses, allowing us to validate or modify them before they reach the servlet. Next is input validation. This is very important because it helps prevent common attacks such as SQL injection and cross-site scripting, also known as XSS. We also need to focus on data protection, sensitive information, and should never be stored in URLs. And session data must be handled securely. Using HTTPS is another essential practice. It ensures that all communication between the client and server is encrypted, and insecure configurations like unnecessary HTTP methods should be disabled. Lastly, it's important to keep libraries frameworks up to date. Using outdated components can introduce known vulnerabilities into the applications. By following these best practices, we can significantly improve the overall security of servlet based applications. So that's all. Thank you.